Welcome back, guys, for the final video in the linked list section of my Blind 75 challenge. We are taking 75 days to solve the LeetCode list of 75 most common coding questions for software engineering interviews. And today we're tackling question 433. It's called Reorder List. But before we get started, don't forget to click that like button and hit subscribe so that you can follow along with me and you don't miss another video update. If you feel so inclined, scroll down and leave me a comment below. I want to hear from you. How much experience did you have with linked lists before? Do you feel confident now that you're at the end of the linked list section? You might be a beginner who's just starting out or an expert that uses them every day. Do you want to see more of these videos, or do you want me to switch it up a little bit? And then what section do you want me to tackle next? Do you want me to go on to graphs, or do you want me to try something with trees? Or do you want me to maybe do some string manipulation? Let me know in a comment below. So with that, let's go on to our last question of the linked list section. It's question 143 and it's called Reorder List. The question asks us this: you are given the head of a singly linked list. The list can be represented as L of 0, L of 1, and it goes all the way up to N. Reorder the list to be in the following form. So what we want is L of 0 and then L of n, L of 1 and then L of n negative 1, and then L of 2 and then Ln negative 2. So as you can see, we're kind of slotting each one starting from both ends and ordering them in a new linked list. You may not modify the values of the list nodes, only the nodes themselves may be changed, so that's super important. So we can't simply go to the end of the list and start swapping values or anything like that. So example 1 gives us the original list 1, 2, 3, 4, and then it expects to get back a list containing 1, 4, 2, and 3. If we scroll down to example 2, we can see that we're given a list 1, 2, 3, 4, 5, and we want to return 1, 5, 2, 4, 3. Hopefully you get the idea. Let's talk through a couple of solutions. So the first solution that you might think of is by using, say, a stack. And you might remember that a stack works in a last in, first out order. So what we can do is just iterate through the list. We can push every single node onto that stack while also checking the total length of the linked list. And then we can just iterate through half of the linked list, popping them values from the stack and inserting them in the first half of that linked list. Let's go ahead and code that up to show you exactly what I mean. So we'll just take care of the expected base case as we always do. So we'll see if the head is equal to null, we'll just want to return. And you'll notice that what LeetCode gives us is a void return type, so we don't actually need to return the list at all. We just need to manipulate that linked list that it gives us. Next up, let's instantiate our stack. So we'll just say a stack of list nodes, and we can just call it stack for now. And then we'll want an integer to keep track of the length, and we'll just set that equal to 0 initially. And then let's start passing through this linked list. So we'll set the first node, which we'll call current, equal to the head. And we'll set up a while loop. We'll say while current is not equal to null. And inside this while loop, we'll want to push onto the stack first. So we'll do stack.push. And we'll push current. Then we'll set current equal to current.next. And then we'll increment length. And we should have reached the end of the linked list by this point. So we'll set current back to the head. And then we'll just iterate through half that list. So we'll set up a for loop. So we'll say int I equals to 1. And then we'll loop while I is less than or equal to length divided by 2 to get to that midway point. And then we'll just increment I every time we pass through. So next we'll want to start popping these nodes from the stack, and we'll want to start inserting them between nodes in this first half of the linked list. So let's set up a list node temp that will just keep track of the current.next. And let's find that ending node. So we'll say end node equal to stack.pop. and we'll set current.next equal to that end node, and then end node.next equal to that temporary node, and then we'll set current equal to temp. So that'll take care of all that insertion. Next, all we want to do is make sure that that last node in the linked list is equal to null. So we'll just set current.next equal null, and that should take care of it. Let's go ahead and submit this code and see what it gives us. Great, so it's accepted our solution. However, as you can see, it's only faster than 23.9% of Java submissions, so it's super slow. And what someone asking this question in an interview style might say is, can you get away with using this extra data structure? That is, can we not use this stack? Well, there is actually a way to accomplish that. What we'll want to do instead is go ahead and find this middle node, and then we'll just reverse that latter half of the linked list. So if we go back to our examples, we've got the linked list containing values 1, 2, 3, and 4. So what we would do in this case is just take the values of 3 and 4 and we'll reverse those. So now we've got two halves of the list in the exact order that we want them in. So all we have to do is start inserting them one after the other. So we'd go 1, 4, 2, 3, and that's exactly the answer that they want us to give them. So let's go ahead and remove this code, and let's break this down into three portions. So first of all, we want to find the middle node of the list. So we'll set up a new list node. We'll call it P1 for pointer 1, and we'll set that equal to the head. And we'll have another list node, and we'll call it P2 for pointer 2, and we'll set that also equal to the head. And then we'll set up a while loop, and we'll use this P2 variable as our fast pointer. So similar to a previous problem, we just want to check if P2.next is not equal to null, and P2.next.next is also not equal to null. And inside the while loop, we'll want to set P1, that slow pointer, equal to P1.next, and then P2, which is that fast pointer, equal to P2.next.next. So now the second part of our algorithm, we want to reverse the latter half of the linked list, and we should already have P1 at the middle of the linked list. So all we need to do is iterate through it and just do that swap manipulation that we did in a previous example where we reversed the linked list. So we'll set up a list node, and we'll want to keep track of that middle node before we did any swapping. So we'll do pre-middle, and we'll set it equal to P1, which should be at the middle of the linked list. Then we'll have another list node, we'll call it pre-current, and we'll set that equal to P1.next. And what we'll want to do is just keep looping while that pre-current.next is not equal to null. And this just checks that we're not at the end of the list. Inside this while loop, we'll set up a list node, we'll call it current, and we'll set it equal to pre-current.next. And then pre-current.next is going to equal to current.next. And current.next is going to equal to pre-middle.next. And then pre-middle.next is going to equal to current. So you can kind of see how we're swapping the nodes around here. By this point, we should have that latter half of the linked list in reverse order. So that is in the exact order that we expect it to be in to be able to splice together these two halves of the list that we have now. So next, all we want to do is iterate through our pointers. One will go from the beginning of the list, one will go from the middle of the list, and we just want to piece together each element as we iterate to the end of the list. So we'll set pointer 1 back to the head. We'll set pointer 2 to the pre-middle.next. So that's the middle part of our list. And we'll want to loop while pointer 1 does not equal to that pre-middle. And then we'll just want to increment through our pointers, splicing together those lists. So we'll write pre-middle.next equal to p2.next. We'll say p2.next equal to p1.next. Then p1.next should equal to p2, and p1 should equal to p2.next, and then p2 should equal to that pre-middle.next. And again, we don't want to return anything in the LeetCode method definition here, so that should do it. Let's go ahead and submit it and see what we get. And we just have a syntax error, so we actually want to call .next. Let's go ahead and submit again. And we've made a spelling error mid-dingle. I don't know what that is, but it should spell middle. And there's another error here, and this is when we've only got one element. So actually what we need to do is add in another check at the top here. So we'll just say if head is equal to null, or we'll say if head.next is equal to null, we just want to return as well. All right, there we go, guys. We've solved the last question in the linked list section of the Blind 75 challenge. If you're enjoying the videos, go ahead, click like, hit that subscribe button, and let me know in a comment down below what you want to see next, which section you want me to tackle. Thank you so much for watching. I really appreciate you, and I'll see you tomorrow for another question.